Thank you. Well, first I want you to know that on my computer, these are all blood red. So just imagine that this is a red talk. I'm honored to be here opening this session today, and I'm going to talk quite a bit more than others about just the special problems of small populations and why they require urgent care. So I'm going to start with a little bit of personal history with endangered cetaceans and Rice's whale, then talk about the special threats to small populations, and then I'm going to end with urgent care needed, a call to action. So unfortunately, I have personally experienced extinction. In 2006, I went out to try to find the last of the Yangtze river dolphin, or baiji. We were hoping to take the last individuals into Oxbow lakes to protect them, but we didn't find any. And this species that had been on planet Earth for 30 million years had already gone extinct. It was too little, too late. I came back to working on vaquitas with a stiffened resolve not to let that happen with vaquitas. And in fact, right afterwards, we published an article that was titled, "Saving the Vaquita, Immediate Action, Not More Data." And by action, I mean for critically endangered species, you need to take steps to eliminate human-caused reductions in survival and/or births. And almost always, action means changing the human behavior that caused the species to become endangered. And I like to use an urgent care analogy. So imagine that a patient arrives in the emergency room with extensive bleeding and likely other life-threatening issues. And the first thing you need to do is stop the bleeding, or you'll lose the patient. And then you can quickly assess other issues and prioritize immediate treatment and give top priority to issues that are both a serious threat to the patient and can be treated judiciously. I shouldn't have put that word in there. I knew it. And then, only then, you can go ahead and conduct tests to gather data to improve on patient care. So my history with Rice's whale really starts after the species was petitioned to be listed under the ESA in 2014, and the agency assembled a group of scientists to assess their status. So I was new to the field and did a lot of reading about the Gulf of Mexico. And we started with this paper by Randy Reeves and colleagues. And the dots that you see in the top figure are actually the noon positions of historical sperm whaling of vessels. And the bottom figure, where you see just a few dots, are actually the either deaths or sightings of a finner whale, which almost certainly was a Rice's whale. And you can see that there's quite a few of those dots that are right south of the Mississippi Delta. Then we had data from the Southeast Fisheries Science Center. On the top, you see both the aerial and the shipboard tracks searching for marine mammals. And on the bottom, you see the locations where they actually saw a baleen whale. And you can notably see that there's nothing south of the Mississippi Delta. And then we were presented with data from the oil and gas industry, and it was a real eye-opener to me how industrialized the central and western Gulf were, being from California. The top figure is actually the oil platforms, and the bottom figure shows the ship tracks to supply those oil platforms. And it didn't really take rocket science to see that there was a negative correlation between where you were seeing whales and where you were seeing very heavy ship traffic. And then we had some of the very earliest data from tags that showed that Rice's whales spent most of their time, especially at night, close enough to the surface to be struck by ships. And now we have more data that show that these acoustic data, what you see, the dots there are long-term recorders, and they can record, unlike the visual surveys, they can record 24/7 for a whole year. And that westernmost one, the WF south of Texas, actually had whales there in every season of the year. So a more extensive distribution than was previously known. And those data feed into models that predict that ship strikes kill Rice's whales at unsustainable levels. And one way to reduce the bleeding is to reduce or eliminate ship strikes. And we already know that slowing ship speed could immediately make a difference to the Rice's whales. I was also part of a workshop that developed this word cloud for the greatest challenges for the species. And you can see a small population right there in the center. And so the team that was evaluating threats to the animals looked at what small population effects were real problems for Rice's whales. And they identified one, a Lee effect, which was the inability to find mates because noise masks mating calls. And the solution for that is less noise. The catastrophic event, of course, we all know about the Gulf Horizon oil spill, which was estimated to kill 22% of the Rice's whales that remained at that time, and the solution to that is to reduce oil spill probability. But the other two small population effects we can't really do much about except get the whales out of the danger zone. So there's demographic stochasticity, which is a chance run of bad luck in birth and death rates, and genetics, which is inbreeding depression, which reduces fitness. And for both of those, you just have to stop the decline. So I'm hoping to convince you that Rice's whales really need urgent care. The best estimate are that there are around 50 individuals remaining, making Rice's whales the most endangered large whale in the world. 50 individuals is not a normal for any species, so it's very likely that this species has been greatly reduced by threats that were present before they were petitioned for listing in 2014. Both Baiji and Vaquita declined very rapidly once they were at this level. And to top that off, catastrophes are known to occur in Rice's whale habitat, making the need to increase numbers immediately to safer levels even more urgent. The status review team also identified a number of high threats where high was likely to eliminate or seriously degrade the population. These were oil spills and spill response, energy exploration and development, genetics, catastrophe, demographic stochasticity, vessel strikes, and seismic surveys. And of those, the ones I've highlighted in yellow are the ones where action is actually possible. So I'm going to return to the idea of the need to stop the bleeding. On my very first recovery team meeting for an Arctic duck named spectacled eider, I came back from the meeting in Alaska, and one of my colleagues said, "Well, how's it going for the eiders?" And I said, "No matter how many reports I write, spectacled eiders just keep declining." And that sounds sort of ridiculous, but my colleague put that on a big poster that I stuck up at my office for my 30-year career with NOAA. And it was a really important reminder that even though writing reports is useful, it isn't actually doing something to save the animals directly. And so you can't really keep them from sliding into extinction unless you take real actions. We already know how to reduce Rice's whales' deaths. We know the situation is urgent because small population factors are already a high threat. And I think we should ask ourselves, is there anything we've learned since 2014 or are likely to learn in the coming decade that will change what action should be taken right now? I'd like to leave you with hope that we can save the patient. Species have recovered in the wild from numbers as low as Rice's whales. The northern elephant seal was down to a few tens of individuals, and now they're in the hundreds of thousands once they were stopped, once hunting was halted. Vaquitas are hanging on against all odds and may have some genetic lessons giving hope to Rice's whales. Natural rarity may actually make these species more resilient to inbreeding depression. We know how to change human behavior to immediately reduce threats to Rice's whales. Delay itself is a threat for critically endangered species. It's time to act. Thank you.
Thank you, Barb. We have time for one question, if there is one, and there's mics located in the aisles about halfway up the auditorium. Please make your way to that mic if you want to ask a question. Okay.
Dr. Taylor, how many Rice's whales do you think there were prior to 2014, or were they ever abundant?
Yeah, the question was how many Rice's whales were there prior to 2014? Patty Roselle's working on that very thing. I think the only way that we have to address that currently is doing what we did with vaquita, and that's looking at the full genome of the species and trying to reconstruct its history and abundance. And that's work in progress. I can tell you, just as a conservation biologist, it's extremely unlikely, even in island populations, that you have fewer than, thousands of animals. So vaquitas were estimated to have roughly 3,000 individuals for the last 250,000 years. And that would be a really unusual case of a rare species. So, you're probably thinking at least in the thousands, but I'm sure we'll find out soon with the genetic research.
Thank you so much, Barb.